Hi, this is JRIT Electronics team presenting the basic lecture on basic electronics. In this course, we will discuss about what are diodes made out of, N-type materials, P-type material, P-N junction diode, the biased P-N junction, properties of diodes, diode circuit models, Q point, dynamic resistance, types of diodes and their uses and sources. Okay, first, what are diodes made out of? Diodes can be made with silicon material, basically silicon or germanium material. Uh, we have different types of diodes. Actually, this diode can be formed with the N-type and P-type materials. By making a physical contact between N-type and P-type materials, we can form a diode. First, let us see what is an N-type material. So, N-type material can be formed by adding a pentavalent impurities to the silicon or germanium semiconductor. Okay, if you add pentavalent impurities to the silicon or germanium semiconductor, then one excess number of electrons is there. So these electrons will freely available to conduct the current. Okay, actually the germanium and the silicon having 4 valency electrons. Okay, if you add the pentavalent impurities, nothing but 5 valency electron atoms to this germanium or silicon, so that excess number of electrons are available. So the charge of this N-type material is a negative. Next one is a P-type material. P-type material can be formed by adding the trivalent impurities to the silicon or germanium semiconductor. Okay, we'll see here trivalent impurity, and there is a vacant space is there. We call it as a hole. So in this P-type material, majority charge carriers are the holes. So current conduction is mostly due to the holes. And next, by making a physical contact between P and a N-type material, we can form a P-N junction diode. This P-N junction diode, this is the P-type material and this is N-type material. This region we call it as a space charge region and depletion region. Space charge region or depletion region. This region will exist because of the potential gradient, concentration gradient existing in between these two materials. For this one, can you adjust? You see the water, how the water will flow from high concentration area to low concentration, or high pressure area to low pressure area. Like that, the electrons will move from high concentration area to the low concentration area, so that they after some time they will get neutralized. So that this will form a space charge region or depletion region. Okay. This is a p-n junction diode and steady state conditions. Okay, we'll see this is a space charge region. Space charge region also called the depletion region. This region includes the net positively and net negatively charged region. The space charge region does not have any free carriers. Space charge region is denoted by the W. The width of the space charge region can be denoted by W. And biased p-n junction, whenever if you apply a forward bias, that is p-type material is connected to the positive terminal of battery and n-type material is connected to the negative terminal of the battery, so that these electrons will move towards the p-type material and the holes will move towards the n-type material. Because of the movement of the charge carriers, will get some current. That current we call as the diode current. Okay, the biased p-n junction, when applied reverse bias voltage is greater than 0, then it gets forward bias. When applied bias voltage is less than 0, it will get reverse bias. Under reverse bias condition, the depletion region width is increases, Under forward biased condition, the depletion region gets decreases and then current is going through the device. These are the characteristics of a PN junction diode. In the x-axis we have taken the applied voltage and the y-axis is the diode current. In the forward biased condition, the current will flow like this. This in the reverse biased condition, these are the characteristics. Okay, at this point onwards, the current starts increasing. Okay, this is about the diode and its characteristics. We will see in the next class applications and where we use the diode. Okay, thank you for watching this video.